23rd, 2022. And it's been a while since we've had a previous meeting. Kind of excited to go over, well, just going to go over a couple of things here. One is to be pretty quick. Let's get right into it. So here's a little TLDR, some highlights. I should have two updates. CAN STM-F1XX driver is not even almost done. It is done. Sorry, I forgot to remove the almost portion when I copied and pasted this over. Yeah, it is done. It is finished.
It's not too first. Are you supposed to be screen sharing?
Oh, am I screen sharing? Oh my goodness. Let's go back here. Sorry, everyone. Yeah, just do the entire screen. Can you guys see this?
Yep, looks good now.
Cool. All right. So that's been done. That's in there. We're good to go. Next thing up is making frequency overflow safe. The frequency class overflow safe. I looked at some of the APIs and realized that there are going to be certain gaps, some overflow situations, because you're multiplying two 32-bit numbers together, and you need a 64-bit number to kind of hold it. I'll go into more details about that later, but that's a thing. And then I'm also working on a micromod. This is very little, less to do with libembeddedhal, but more to do with making sure that there's a platform that people can use to develop their stuff off of. So I'll go into that later on. And then finally, I kind of pulled a Elon. So we have about 6-ish, more like 5-ish months to kind of get some stuff launched. I'll explain that in a little bit. All right, so first off, making frequencies overflow safe. So all frequency APIs have been modified to ensure that multiplication does not overflow beyond 64 bits. Reason being, one, trying to represent more than 64 bits on like a system that's 8-bit, 16-bit is a bit excessive. But even on 32-bit systems, having a 128-bit number, doing all the computation for that just adds a lot more machine code. But gives us a lot of good things if we had that. But honestly, none of those reasons actually even matter as much as the fact that there is no 128-bit number in the C++ standard. So we're pretty much limited to 64 bits, and there's particular reasons why 128 can never be added into the standard. I'm not going to go into those details, but it has to do with the implementation for int max. So we need to make sure that when we're doing multiplication that we have something to hold that in. So really we want to make sure we do is either we need to understand the range of values when multiplied and divided, what they kind of come out to be, or we need to make sure that we only do a multiplication once or twice or whatever. So that's a thing. By making everything overflow safe by nature and by the API design, this ensures that our code doesn't really need to have any error code return values, and also doesn't require our users to have to error check our values after computation. This is just a way to optimize code, but also it allows the user to fully understand when they try to use the API, like, hey, if you do this, you're chopping off the top. So you need to keep that in mind when you're doing these calculations. So pretty much just limits almost all of our inputs to 32-bit. I'm still working on making sure this is done everywhere. Cycles per is one of the APIs that doesn't do this currently because it can take a template where we take basically a duration with a certain representation in a period, and that representation can be anything, including 64-bit or above, and that's problematic. So I'm going to lock this down a bit. I think I'll just I'll lock this down somehow. Probably just make the input nanoseconds. So still figuring out how to change. Still looking into how to change this. Finally, this effect does affect the uptime calculation because 32-bit counts of nanoseconds can only represent 4.2 seconds at nanoseconds resolution. So to make this work, we have to basically accumulate the results of each successive calculation. That's just to say that if we look over here at some of this code, I really do hope that this code has been transferred over, because otherwise I'm not sure where it went because it's been a while since I looked at it. Yeah, so for uptime, so we have this new kind of implementation of uptime counter. You give it a counter, and it basically will return back nanoseconds. And what it does is it gets the up count, and the up count now comes with the frequency and the uptime, rather than just having them be separate functions. Because really, that's all you really need out of this is just what the frequency is associated with that count. And you don't really need a separate API to get back frequency. It's almost always just returning some local variable. So I'm kind of returning them both at the same time. From here, we subtract the new uptime by the previous uptime, get the time delta, and then pass that through to duration from cycles. That'll give us the nanoseconds delta, add that to our last uptime, and we pretty much have the uptime since we started. As long as you call this function within, if you have something running at 1 gigahertz, within every 4 point something seconds, this will always succeed. This will always work. This will keep track of reality and keep track of time really well. If you go outside that, you're basically hosed. But also on top of that too, at lower frequencies, the speed at which you have to wake up in order to update this goes down because it doesn't take if you're at 1 gigahertz, it'll obviously take longer for you to get through this whole cycle. Same thing with if you're at, or longer if you were to half a gigahertz or a quarter of that. So that's just that. So that's something that I've been working on because I realized that the previous code had this particular flaw where you'd overflow, and it overflowed a very particularly weird number, and I just didn't like how that code was looking and how there's so many weird edge cases I had to deal with, whereas we can eliminate all those edge cases and all those situations by simply just making everything overflow safe. Any questions about this? Cool. Moving on. We have LPC 4078 Macromod V2. Want this to be a cheaper alternative to the SJ2 board. Just a mic check. Am I still online? I just heard a little blurb.
Yeah, we hear you.
Cool. All right. Cool. Working on a cheap alternative to SJ2 board that is compatible with the Macromod system. Smaller footprint means a cheaper PCBs. Part count is limited to just a few components needed for Macromod, reducing cost. I'm switching out some really, it's only two ICs, which is the CH9102F and the LPC 4078. Side note, I was super excited to find this particular chip. It's made by the people who make the CH340 chips, which are USB to serial chips that are much, much cheaper than things you can get from FTDI or Silicon Labs. FTDI and Silicon Labs, I believe, are both American companies, and their chips are way more expensive. Reliability is, depends which one you buy. But this Chinese company, WCH, built this chip, which is a direct replacement for the chip we use on the SJ2 board right now. So I was pretty happy to find this because it's much, much cheaper and it's available, unlike the other chip, which I believe goes for, I was asking my distributor for my manufacturer for China for making PCBs. And those chips go for $22 right now. The CP2102Ns, because you're getting scalped. So that's fun. So aside from that, we're going to get this getting this to work on JLC PCB and also using almost entirely LCS components, so that ordering becomes as simple as you go to my thing on EZDA, click order, and then it just does everything for you. That's the dream. That would be fantastic if that was the case. Who just jumped in? Oh, cool. All right, so next up, and then, actually, any questions on this before I move on? Cool. All right, finally, pulling an Elon to the moon. The deadline should really be around about 5-6 months. I kind of go back and forth between this and this slide. I need to correct this. I think I'm just gonna say 5 months. Rationale here. So September 1st is when I'd like to launch on Conan. On CBcast, I stated that I believe that we can launch in around 6 months, and that around that time I would be willing to go back on, talk about it, and advertise it there, as well as also posting it on Reddit, and just getting around from r/firmware, arm/CPP, arm/ things like a CPP projects type thing that can throw it on there as well, and then I might even place it around some other locations as well. But I want to kind of start here. But in order to make this thing work, we pretty much have the following 10 modules, 12 APIs, 36 peripheral drivers, 5 device drivers, and 1 RTOS to launch to Conan in order for this whole ecosystem to look full enough for people to even be interested in trying to use it. So this would include the following first iteration of APIs. So that would be output pin, input pin, interrupt pin, PWM, ADC, SPI, I2C, serial, counter, timer, CAN, and DAC. I was kind of debating whether I should put CAN on there, but I think we can come up with a very simple API for CAN and be good to go. Launch for peripherals, I would like to have libelpc40, STM32F10X, and STM32F4XX. Basically have all the top APIs implemented. So that is 12 APIs times 3, effectively. And then next level would be launch the following device drivers. These actually should be relatively easy to do. MP6050, librmdx, shouldn't be too hard. libGPS module, I don't know which one we should use for this one, but we can use any one of them, honestly. libsharp distance and libsd card. The idea for a lot of these is to use APIs that people may not be able to. Basically, for every API that makes sense to have some library that utilizes it, I want there to be. Well, for the most part, I really just want there to be some driver that uses it so people can have an idea of what it's supposed to be used like. So, for example, sharp distance uses ADC, although So like when I say about sharp, I don't mean like a sharp distance. I'm talking about like the sharp company and their IR modules, and they have distance sensors for them. That'd be like an ADC implementation because the waveform isn't like a linear equation, isn't literally linear. So that would be something someone will work on. MP6050 uses I2C. librmdx uses CAN. libsd card uses SPI, and then libGPS module will use serial. I could have used ESP8266 as the implementation for serial, but I thought maybe that's a little too complicated, honestly. It may not give the best look for what I'm looking for. And then finally, we need an RTOS to run off of so people can integrate that into the system as well. I plan to post down a burn down chart on sjsudev2.org by next meeting. So we have like the list of everything that's there. But I really just want to say that I really just want to say that so I just got a message from someone else. I'm gonna need some help to get all this stuff done. I think a lot of the stuff is in a pretty good space for the most part. I think a lot of the APIs are pretty much in a good space. I think counter I'm pretty settled on. PWM, what does PWM even look like? Let's see. PWM. Frequency is a setting and configuration setting, and then we have duty cycle. Yeah, that seems perfectly fine to me. I feel like a lot of these are actually probably in a good spot, but if you want to look over them and make sure they make sense, please do. But what's really going to be necessary actually is writing down implementations for these, which is actually probably the hardest part because each peripheral driver has a lot of things it has to keep in mind in order to make sure the namespaces are clean, you're not bloating the code, and that you're making it really easy for the user to be able to do the right thing when it comes to using our peripheral drivers. So that is the thing. Next up, we have device drivers, which is a bit easier conceptually, I believe. But we still need to make sure that you have these things right and we're doing a good job on these so that they look clean, they look professional, they look like good implementations to represent the libembeddedhal. Then finally, probably one of the more complicated ones is FreeRTOS. Is a way to get FreeRTOS to fit with libembeddedhal's ecosystem and how it does things, and probably not trying to do C++ify it. That I don't think is necessary, especially at this stage. I think maybe we can do that in the later stage, but I think just getting a implementation that just integrates in is helpful. And some way to have this modularly fit into libLPC40XX and stuff like that. Oh, I did forget one. I knew I forgot something. It's gonna change everything. libarm Cortex. But that one isn't actually doing all the APIs above. It just does all the ones that it can support. So that one doesn't really need to be there per se, but I'm just adding it to this little section here. But yeah, no, there's a lot to be done. So I'm going to start creating a whole bunch of items just like that. But if you have any one of these that you're interested in, please ping me or ping like in the group chat which ones you're interested in. Cool thing about libLPC40XX is that you can pretty much just like, you have a whole bunch of reference designs, so you can just follow what is there and then try to make it work here. Same thing with libLPC STM F1OX. F4 is not the same, but because it's so close to F1OX, it's really easy to use the other one as a reference design as well. And then libarm Cortex is nearly done, I feel. I'm still working. I think I'm going to go back and fix up some things. I think for the most part, it's a good stage where I can kind of lock it down. Everything else here is still up for grabs. So if you have anything in particular or a suggestion on what GPS we should use for this, please notify me or post it on the discussion chat. And that's pretty much the entire meeting, is just talking about how I want to get back into this, want to put a lot of effort in this. I've been moving, I've been having internet problems, Also trying to move jobs as well, so I've been a little bit like out of the picture for a bit, but I want to come back strong and have us really come together to work on getting this particular project to launch, because I think there are a lot of people who really, really, really want something like this, and we have certain examples out there that I believe just don't do it justice for building a platform and a set of APIs, a set of standards for how we do embedded coding. So if you guys can help me out to make this thing a thing, so we can make this available to all C++ programmers, I think that would be pretty swell. So any questions?
Yeah. So just to recap a little bit, the goal you're trying to do here is, so most of these drivers for these various MCUs are already done in SJC-Dev2.
Yeah.
Your goal here is to move them over with the new library structure to libembeddedhal.
Yes, correct.
Okay.
Yep, that's pretty much it. And to libembeddedhalify them in any way that makes sense. So if you see like an improvement that can be made given the new code base that we have, please utilize it. Every bit of like, as long as what you're doing makes sense, but for the most part, it's every little bit of stuff that we got improved from prior project to this one. We want to make sure we do them right here. Like MPU 6050, or actually maybe that's not the best example. Maybe you have to calculate something like some frequency thing in MP 6050 or something like that. Well, use a frequency library because that'll help you out. Make sure to refrain from floating point arithmetic so we can, we can save on flash memory for systems that don't have it, that kind of thing. So yeah, it's mostly just porting things over, but I think we may need some new things like GPS modules. I don't think is anything we have currently, so it might be good to have that in there.
Yeah, and I don't know if all the drivers for STM32 were done.
Yeah, no, they're not. Especially not for F4XX, and there's quite a few.
Yeah, there's like none.
Yeah, it's like pin. I think that's about it. I think here's the reason why. Most of the drivers for STM F10X basically port over to STM F4XX. Kind of like how the like LPC40, almost all of its drivers match with the LPC17 or vice versa. So that's one of the reasons why if we just get one of them done, you can actually just all you have to do is take the same exact code, but point the registers to different locations in order to make STM4 work. So
something I need to do for the CAN library, which I just completed.
Yes, the CAN library, I actually looked into it, is pretty much identical. So all we have to do is change the location and it works for FX4XX. We just have to make sure that all you have to really do is say, oh, I'm gonna have libst STM32 F4XX depend on STM32 F10X. And you can either, and I haven't figured this out yet, what we should really do, but probably inherit from one F1's CAN bus driver, or we can just do a has a implementation, just call the other driver's stuff through it. But I think the main thing is making sure you get the addresses assigned differently, or like you have the addresses assigned for the appropriate system you're on.
I'm off the top of my head, maybe we should make a base class for STM32 and then create the derived classes for F1 and F4.
Yeah, only issue with that is I don't know how much of the peripheral blocks are totally consistent between all the F series. But if you can do an investigation, so yeah, actually most of them are consistent with each other, and we can just have like a lib STM32 F library, and then kind of just go from there. I think that'd be swell. I was even considering making a lib LPC, but I haven't done the research to know if LPC 11 and LPC 15 are the other ones. I'm pretty sure 15 was a real one. If they also have basically they reuse the same peripheral blocks across the different chips. So I don't know if that's consistent, if that's a real thing. If it is, we should totally crunch this down into those. If it's not, then it depends on if we want to
take some investigation.
Yeah. I will say though, if we find out that they're not and they're pretty separate from each other, I think it's also totally fine to say, hey, these particular libraries depend on each other, and really, actually, so what we did for LPC 17 is that we actually aliased in the namespace for LPC 17 the same library for LPC 40. So basically, it's as if you're basically pointing to the same thing, and your getter function that you have will basically either A, change depending on what platform you're using, which actually would make this make it kind of easier to write, maybe potentially, or you have separate getter functions for either one. We'll see how which one works out the best. But
Yeah, that's super interesting. Didn't realize he did that. I'll have to look into that.
actually, that's If you look at SJDev2s, you'll see it there. Yeah. Any other questions? Alrighty. Cool. So yeah, that's pretty much it for this meeting. Please hit me up if you guys have anything in particular you guys can work on, or hit me up and say, hey, I won't be able to really like help out as much, or I won't be able to help out until a little later on, just so I have like an idea of where people are at right now, because I think that'd be very helpful to know, so I can plan things around accordingly. Yeah, that's pretty much it. Oh yes.
I can just say 2 quick words for
Yes.
anyone who is still at San Jose State and doesn't have a job. These projects will be super helpful for you in the future, because if you can have this get shown in your Git repository, this is something you can link in your resume. And for prospective employers who are trying to look through candidates, seeing something on your GitHub is extraordinarily helpful to filter through candidates. Because where I work, I've recently been interviewing a number of people, and basically if they don't have a GitHub, that's been a big negative for me in filtering them out. So just wanted to give those 2 cents.
Yeah, thank you very much, Matt. So yeah, I want to reinforce that, signal boost that real quick. Like if you design things correctly and you actually have this thing, deployed and used by other people, being downloaded everywhere else, that's impactful. That's huge. And trust me, when it comes to you compared to your other peers, it's unlikely that many of them will make impact to that kind of level where they have actual clients using their stuff from the past. Technically, that was a thing with SJDev too, but it was within SJSU. Now you're gonna have it go like potentially global. Who knows who might be using it. Maybe some Chinese company sees, hey, this is one little library that these people in San Jose, California made. Let's try to use that. Or some other like small startup in Mountain View decides, hey, we saw this one thing, maybe this will make our lives a little easier if we just use it. That kind of thing. So a lot of impact there, and a lot of people do look at your GitHub to see if there's anything of use there or anything that's good there. And a lot of time people will just put pretty GitHub becomes a dumping ground of files for whatever reason, or whatever types of files or for whatever. But when you have something that's like, oh, this person contributed to this particular open source project, massive. I don't think I need to tell everyone this already, but that's just huge, and made me telling people that I work on my open source projects got helped me to get into one of my other offers that was for a really interesting startup. So yeah, if there's no last questions, I think we will wrap it up. Alrighty, thank you guys.